Hello and welcome back. This is Greg French. Today we're going to be starting Chapter 5 of our A+ Computer Repair series, CPUs and Chipsets. This is Chapter 5, Part 1. Objectives. We're going to learn about CPUs used for personal computers and notebook computers. Learn about the chipsets and how they work. Learn how to keep a CPU cool. Learn how to install and upgrade a CPU. Introduction, the CPU and chipset. Most important components on the motherboard. The CPU is what we call a field replaceable unit, FRU. That's a good test question. The chipset is embedded on the motherboard, so it's actually a part of the motherboard. It's nothing that you can actually remove or socketed. Important skills we're going to learn. Making wise purchase decisions and installing and upgrading a CPU. The CPU and chipsets are located on the motherboard. The components determine the power and the features of the system. Major manufacturers, we have Intel, AMD, and Cyrix. Intel by far, over 80% of all the CPUs ever made are probably Intel. Intel still carries a considerable lead. AMD was catching up there for a while, but then Intel just took off again. We'll talk a little bit about some of the advantages of the AMD chip and some of the advantages of the Intel. Factors used to rate CPUs. System bus speeds are very important. An example would be 1066 megahertz, which would be a fairly fast bus speed. CPU core frequency is normally in the gigahertz. So our bus speeds are generally in the megahertz, but our CPUs are up in the gigahertz. 3.2 gigahertz for a CPU. Word size, 32 and 64 bits. We'll talk more about the word size and the data path size, 64 and 128 bits. Multiprocessing ability and the CPU cache memory. Some very important features. Efficiency and functionality of the programming code. Type of RAM, motherboard, and the chipsets supported. All very important factors. How a CPU works. Three basic components of the CPU. Input-output, control unit, one or more arithmetic logic units, which is the ALU. We'll be referring to that acronym a lot. Registers used by ALU. Internal cache holds data to be processed by the ALU. The internal cache of the CPU is going to be something we're going to see as a very important performance factor. Two types of buses. We have an internal front side bus. Data portion is 64 bits wide, and an internal or backside bus, usually 32 bits wide. Here's a diagram of a CPU on the left-hand side here. You can see here's this memory cache, and connected to it is what we call the backside bus. We have two sets of registers, two sets of ALUs, and the internal data bus size is 32 bits on this particular processor. Today we see mostly 64. Then the front side bus, which connects us to the rest of the computer, is located right here. Front side bus has been 64 bits wide for quite a long time. Since 1983, the standard has been for a processor to have two arithmetic logic units so that it can process two instructions at once. How a CPU works continued. System bus frequency or speed, faster than other buses. 1066 megahertz, 800 megahertz. CPU frequency or speed refers to the speed or internal operations. 3.2 gigahertz would be an example of that. Now the system bus frequency times the multiplier equals the CPU frequency. So our system bus frequency, which can be the bus on the motherboard, we multiply that by our multiplier and boost it up to where we get to the CPU frequency. So everything is working off a single pulse or a single clock frequency. Overclocking would be running the CPU at an excessive speed, which does produce a lot of heat, but it can be done successfully on a lot of the processors. Throttling is decreasing the speed when either overheating occurs or when it goes in maybe into a standby condition to reduce the amount of power being used. Data size, data path size, and word sizes. The data path That's where it transports the data into the CPU. The word path is the number of bits processed in one operation internally on the CPU. How a processor works continued. Multiprocessing, the simultaneous processing by two or more ALUs. Multiprocessors platform contains two or more processors. Generally, that's what we see today is at least a dual core. Dual core processing, processors share the same bus but have separate cache. Memory cache, this is the static RAM, SRAM, holds data as long as power is on. Lets the CPU bypass slower dynamic RAM. The L1 cache is on the CPU. The L2 is external. And that's changed quite a bit. Today we have L2 and L3 now on board. But the L1 cache really determines the performance of the CPU. The more the cache we can put on there, the better. But the cache on the CPUs today can run as much as the entire CPU. So Intel has been fairly stingy on the amount of cache that they've been using on their processors in the past. But today that's changed because of AMD's doing some performance enhancements. They've been forced to increase the amount of cache in order to take back market share and increase the performance of their processors, so that they're now doing a little bit better than AMD. But here's a diagram of the AMD dual-core processor using two Optron processors in the single processor housing. One of the big things that AMD came up with was this crossbar technology and integrating the memory controller, which for Intel is on the North Bridge, right directly into the CPU. This was a big performance improvement, and AMD took the lead in the CPU performance for quite a while until Intel came up with some better performing processors. It's good to have competition. Competition is what really pushes this technology. Here's a diagram showing how the cache memory is used to temporarily hold data in expectation of what the processor will require next. Very important engineering has gone into developing this cache performance. A good story is when the Celeron was first introduced, Intel came up with a very, very small amount of cache memory for it. So they took a lot of extra engineering to help increase the performance, and they increased the performance so greatly that it surpassed the Pentium 2 chip. So it immediately retired the Pentium 2 chip because the Celeron has always been the lesser expensive chip. In review, CPU. We talked a lot about the CPU, talked a lot about the cache. Now, level 1 cache, level 2 cache, and level 3 cache. Level 1 cache is the most important cache. That's the cache that makes instructions and data readily available to the CPU. If there is a miss on the level 1 cache, it will go to the level 2 cache. If there's a miss on level 2, it'll go to level 3. It used to be level 2 was on board the CPU, but that took quite a performance hit on the CPU, so they've moved level 2 and level 3 now on board the CPUs. ALU, arithmetic logic units on board for helping to process the data. Activities. I want you to research the latest CPU technologies of both Intel and AMD, see what they're working on, and be ready to discuss. Also want you to do Lab 5.1, the CPU, and turn in the review questions. That's it for this first lesson, part 1 of Chapter 5. Thank you very much.